Okay, this is the second lesson on the chain rule, which is when we're differentiating a composite function. Just a couple of things to remember before we start. When I see something like this, sine to the power of 4 of x, that is not the same as sine x to the power of 4. In this first example, we take the sine of the x first, and we raise that answer to the power of 4. In this example, we raise x to the power of 4, and then we take the sine of that answer. So there's two completely different things, please don't confuse them. This one on the left is a composite function that we'll be dealing with more often, and we can rewrite it with brackets, because that always helps us when we're using the chain rule. It's the same as sine x all raised to the power of 4. One more quick note before we start. The derivative of 7x plus 2 pi is just 7. The 2 pi is a constant. The fact that it's got an irrational number in there doesn't matter. It's the same as if we were differentiating 7x plus 6. Because this is a constant, it's unaffected by the value of x. We ignore it when we're differentiating. We're going to go back in our notes to page 20. Our first example is y equals the cos of 5x plus pi over 6. It's a composite function. Inside the brackets I've got 5x plus pi over 6. Outside the brackets I've got the cosine. So we're going to differentiate the outside first. Now cos goes to negative sine. I'm leaving the brackets alone. And then I'm multiplying by the derivative of what's inside the brackets. If I differentiate 5x plus pi over 6, I just get 5. Now I'm going to tidy up. It's negative 5 multiplied by the sine of 5x plus pi over 6. We're going to nip to page 21 and fill in example 2. The example is y equals 2 times sine to the power of 4x. I'm just going to rewrite this with brackets so that I don't make a mistake when I'm differentiating. Now I'm going to take the derivative by using my normal rules. I'm going to multiply by the power, so 4 times 2 is 8, leaving the brackets as they are, and reduce the power by 1, 3. Then I'm going to multiply by the derivative of what's inside the brackets. Derivative of sine x is cos x. So when I tidy this up, I'm going to have 8 times sine cubed x times cos x. And finally, I'm going to move on to page 22 for the final example, which is example 6. And we're given the function y equals the sine of 9x plus pi. Now there are already brackets in there, which is good. If there aren't, I would be wanting to try and add some in. There's brackets in there, so I'm going to deal with outside the brackets first and then inside. So we'll do y by dx. Sine is on the outside, that differentiates to cos. Bracket stays the same. And I'm going to multiply by the derivative of what's inside the bracket. Well, the derivative of 9x plus pi is just 9, because remember pi is a constant. Tidy that up. I've got 9 times the cos of 9x plus pi. Okay, so the only thing to remember today. What can you add into a function to make the differentiation easier if they're not naturally occurring? Now we're ready to do the 3 exercises that we started before, but we're going to be going from question 2. We've got level C for 14A and G and AB for H.